Hey, Math 20-2. Today we're going to look at confidence intervals and margin of error. So in this lesson, we're going to interpret statistical data using confidence intervals, confidence levels, and margin of error. Note, the focus will be on the interpretation of data rather than on statistical calculations. Introduction Part 1. So I want you guys to read through Introduction Part 1. You guys can do that. Then you can go over to the next page and read through Introduction Part 2. All right, so that's your job. Read through that stuff. Make special note of these definitions. Margin of error, confidence interval, and confidence level. So read through all those things. Once you've done that, come back here, we'll start doing class example number 1. All right. So in order to determine the mean mass of golf balls produced at a factory, sampling is done and the following statements made by the company. The mean mass of golf balls produced at our factory is 45.6 grams plus or minus 0.3 grams. The results are accurate 19 times out of 20. Determine the confidence level. So the confidence level is 19 out of 20 or 95%. The confidence level, recall from the definition, is the likelihood that the true population proportion lies within the range of the confidence interval. So if it's accurate 19 times out of 20, it's accurate 95% of the time. Determine the confidence interval. All right. So we're told it's 45.6 grams plus or minus 0.3 grams. So we're going to take 45.6 and subtract 0.3 and then 45.6 and add 0.3 to give us our confidence interval. Therefore, our confidence interval is 45.3 to 45.9. Part C, state the margin of error. Well, the margin of error would be plus or minus 0.3 grams. Part D, is it likely that the mean mass of golf balls produced at this factory is 45.1 grams? Well, think about this and see if you can answer it. Pause it and do that. So I would say no. 45.1 is well outside our confidence interval, and only 5% of the time is that going to occur where we get a value outside of 45.3 to 45.9. All right. Part E, is it possible that the mean mass of golf balls produced at this factory is 45.1 grams? Yes, that's possible, but it's highly unlikely. All right, so you could write that in there. So yes, it's possible, but it is unlikely. All right. All right, so let's see the effect of sample size on margin of error and the size of the confidence interval. All right. So the 2011 Canadian federal election took place on May 2nd, 2011. A large number of opinion polls were conducted in the days leading up to this election. The table below gives the results of 4 of these polls. The data represents the percent of the sample who would cast their vote for each party. Some of the results do not add up to 100% because voters from minor parties and independents are not included in this table. The results are accurate to a stated margin of 19 times out of 20. We know that to be a 95% confidence interval. All right, 95% confidence level. All right. So if we scroll down here, it tells us, A, look at the columns for number in sample and margin of error. How does the sample size affect the margin of error? So let's have a look at those. Number in sample and margin of error. So let's just have a look and compare those things. What do you notice? Well, we should notice that the larger the number in the sample, right, the larger the number in the sample, what's happening to our margin of error? The smaller the number, the smaller the margin of error. right. Part B, for each polling firm, calculate the 95% confidence interval for the percent of Canadian voters who would vote for the New Democratic Party and complete the table. All right. So you want to go back up to the top, and at the top of the table we want to see what the percentage is for the NDP and what the margin of error is for each of these. So for Harris Decima, it's 30% with a plus or minus 3.1% margin of error. So 30% plus or minus 3.1. So what is that confidence interval? Well, 30 minus 3.1 is going to give us 26.9. And 30 plus 3.1 is going to give us 33.1. So there's our confidence interval, 95% of the time. All right. Do the same thing for Angus Reid, Nanos Research, and EKOS Research, and see what you come up with. So from the table above, we notice that for Angus Reid, 33% is NDP, and it's got a margin of error of plus or minus 2.2. So that gives us a confidence interval of 30.8 to 35.2. For Nanos Research, 30.6% of the vote went to the NDP with a with a margin of error of 3.0 plus or minus. So that gives us a confidence interval of 27.6 to 33.6. And EKOS Research, 31.2% of the vote went to the NDP and had a margin of error of plus or minus 1.8. So that gives us a confidence interval of 29.4 to 33. All right. For each polling firm, calculate the 95% confidence interval for percent of Canadian voters who would vote for the Conservative Party and complete the table. So do the same thing we just did, but now do it for the Conservative Party. All right. Way you go. So there were the confidence intervals for the NDP. For the Conservatives, with Harris Decima, 35% voted for the Conservatives with a plus or minus 3.1 margin of error. So that should have been 31.9 to 38.1. Angus Reid had a 37% Conservative with a plus or minus margin of error of 2.2. So that would have given us 34.8 to 39.2. Nanos Research had 37% of the vote going to the Conservatives with a plus or minus error of 3, so that would have been 34 to 40. And EKOS Research, 33.9% with a margin of error of plus or minus 1.8, so that would have been 32.1 to 35.7. All right, so we've got this table completed. Part 1, in which of the polling firms is there no overlap of the percents in the confidence intervals between the Conservatives and the NDPs? So we notice that the lower limit here is 31.9 and the upper limit here is 33.1, so there is an overlap with the Harris Decima one. Angus Reid also has an overlap. 34.8 is low here and 35.2 is the highest there, so there's an overlap there. EKOS also has an overlap. Lowest here is 32.1, but the highest here is 33. So the only one that has no overlap is the Nanos Research. So what that means is, in the Nanos Research case, since there's no overlap, we can say with 95% confidence that the percent of Canadian voters who will vote Conservative is greater than the percent of the Canadian voters who would vote NDP. Part 2. In which of the polling firms is there an overlap of percents in the confidence intervals? Well, we just said all the rest. All right, everything but Nanos. And then in these cases, since there is an overlap, we cannot say with 95% confidence that the percent of Canadian voters who will vote Conservative is greater than the percent of Canadian voters who would vote NDP. So in which of the polls can we say with 95% confidence that the NDP will receive a higher percentage of vote than the Liberal Party? So you'd have to go through and do the same thing as we did with the Conservative Party. So go ahead and try that, and then you can see what the answer is. So if you did the work like I did, let's go back to the table. up here. So the Liberals, I filled in all their information. And we notice in the Harris Decima, there's no overlap between the lowest and the highest. Same with the Angus Reid. Lowest NDP doesn't match the highest Liberals. Same with the Nanos, there's no overlap. And same with EKOS, there is no overlap. So to answer part D, in which of the polls can we say with 95% confidence that the NDP will receive a higher percentage of votes than the Liberals? We will say all the polls. So in all the polls we could say that. Part E, in which of the polls can we say with 95% confidence that the Bloc Québécois will receive a higher percent of vote than the Green Party? So you'd have to go through and do the same thing we just did for Bloc Québécois and the Green Party. So I'd like you to try that and see what you... So here's what we should have come up with. If you do the confidence intervals for Bloc Québécois and confidence intervals for the Green Party, here's the Harris Decima, Angus Reid, Nanos, and EKOS research. And do we find any overlap? So again, we're going to see overlap in this one. There's overlap between the lowest and highest. We see overlap in this one. We see overlap in that one. And we see overlap in this one. So we would say in none of these. None of the polls. Could we say with 95% confidence that the Bloc Québécois will receive a higher percent of votes than the Green Party? All right. All right, let's jump ahead to the next page, the effect of sample size on confidence level. All right. If you want to be 100% confident about the results of your measurements, you would need to measure the height of every student in your school when we talk about what is the mean height of all the students in your school. Suppose the sample mean height of the students is 67.5 inches, and we state a confidence interval of 66 to 69 inches and a margin of error plus or minus 1.5. If in our sample we had measured the heights of more than half the students in the school, our level of confidence that the true mean lies in the confidence interval will be very high, well above 99%. If in our sample we had measured the heights of about a quarter of the students in the school, our level of confidence that the true mean lies in the confidence interval would still be pretty high, but not as high as in the case above. And if in our sample we had measured the heights of only a few students in the school, our level of confidence that the true mean lies in the confidence interval would not be very high at all. So circle the correct alternative in the following statement. For a fixed margin of error, the confidence level increases or decreases as the sample size increases. So as we have a larger sample size, our confidence level will increase. All right. Example 2. A company purchases hockey pucks. League regulations state that the weight of a puck used in a game must be between 164 and 170 grams. The production equipment is set to produce pucks that have a mean mass of 167, and the standard deviation has been calculated to be 1.1. Quality control testing is done on a regular basis to determine if the pucks produced meet the standard requirement. To ensure that only a small number of pucks produced are rejected, the quality control manager must ensure that the mean mass of the pucks lies in the range of 166.7 to 167.3. During each workday, a random sample of pucks is selected and weighed. The table below gives the sample size needed for different confidence levels. A. State the confidence level for the interval 166 points. State the confidence interval the company is using for its quality control tests. Well, they told us that up here, 166.7 to 167.3. 166.7 to 167.3. That is the confidence interval. State the margin of error. Again, they told us, well, they didn't really tell us that. But if I know that the mean that they want is 167, so if I know the mean is 167, then I know the confidence or the margin of error is plus or minus 0.3. And part C, how many pucks should be weighed in each sample if the company wants to ensure that the mean mass is in the range 166.7 to 167.3, 49 times out of 50. Well, 49 times out of 50, 49 out of 50 is 98% of the time. So I look up here, 98% of the time means a sample size of 73 pucks. So we need to have a sample size of 73 pucks. All right. Part D. Pucks which do not satisfy the league regulations can be used in practice. How many pucks should be weighed if the company wants to ensure that the mean mass is in the range 166.7 to 167.3 9 times out of 10? So 9 out of 10 is 90%. You go back and look where 90% is. 90% is 36 pucks. So they're going to want to measure 36 pucks. And E, if the company were willing to accept a mean mass in the range of 166.6 to 167.4, would they need to test more or less pucks than in the table in order to attain the same confidence level? Well, if they're going to open up their confidence interval here, then they will need to test less pucks. They don't have to be as accurate, so we don't need as great a sample size. All right. Use confidence intervals to interpret the following statement. A recent survey showed that Canadian high school students spend on average 1.5 hours per day accessing the internet and an average of 1.75 hours per day being physically active. The results are considered accurate to within 0.2 hours 24 times out of 25. So using confidence intervals, let's interpret that statement. All right. Well, 24 to 25, that is a percentage of 96%. All right. So we can say with 95% confidence right, that's our confidence level, with 96% confidence. 96% confidence. 24 to 25 is 96%. So we can say with 96% confidence that Canadian high school students spend between well, let's talk about hours accessing the internet. So between 1.3 and 1.7 hours per day accessing the internet. How did I get that? Well, 1.5 hours per day accessing the internet, and they're accurate within 0.2 hours. So 1.5 minus 0.2 is 1.3, and 1.5 plus 0.2 is 1.7. All right. We can also say with 95% confidence, and we can also say that between 1.55 and 1.95 hours per day being physically active. Again, we were told 1.7 hours a day being physically active within 0.2 hours. So 1.55 is 0.2 less than 1.75, and 1.95 is 0.2 greater than 0.75. What else could we say? Well, based on this information, we could say it is likely that most Canadian high school students spend more time being physically active than on the internet. All right. So you have your assignment. Away you go.